more than one event happening in today's lesson. So there'll be like 2 events or 3 events happening. And it's really easy to figure out the probability of more than one event happening because you actually just multiply the probabilities of each event. Now here's the key. The question is, does the first event change the probability of the second event, everyone? Do you see what I'm saying? Because that could happen. A very common example of this is if you have marbles in a bucket and you draw out a marble, then that now, if you don't replace it, is going to affect the probability of the next draw. Do you guys see what I'm saying? Because that changes the total in the bag. So kind of like your problem that you brought up to me, you know what I mean? So just things like that. If you put the marble back in, aren't the totals back to normal? Do you guys see? So that'd be independent. So listen, if I said to you, here's a bag of marbles and there's 5 red and 8 green, what's the probability that you'll draw a green and then a red, not replacing the first marble? So that would change from the first draw to the second draw. If I said, what's the probability of drawing a red then green, but replace after the first draw, that would change. But either way, you multiply both probabilities together. So dependent would be dependent events, influence. Remember that you're not allowed to talk when I'm teaching, and if you think you are, you're going to be switched into Jones class at this point in the year. And I have done it before, and I made a kid cry last year because I walked them down to the counselor and we switched them into Mr. Jones class. I really did. There was 2 boys that
Do you have any regrets about that?
No. I got told I was the worst teacher ever by their parents, and you know what? It gave me joy. I'm going to back there. I'm going to switch you back into Jones if you guys don't stop talking. It's not an empty threat either. Like, these boys kept thinking it was an empty threat, and so I was like, wow, now that I've said it, I have to follow through. I did. All right, everyone, focusing. Dependent events influence the probability of other events taking place. Independent events will not affect the probability of the next event happening. Okay, so it's really easy. You're just going to multiply each event's probability together. Then right here, this is the same thing. You're still just multiplying each probability together. You've just got to take into consideration, like, okay, there's already an event that's happened. This is really overcomplicating it. So we're just going to get to an example right here. You roll a 6-sided dice 6 times. The dice shows an even number. So even, the first 3 rolls, and then odd, the remaining 3 rolls. People in back, what don't you understand about when I'm teaching it's not allowed to talk? Digging my own eyeballs out, ready to jump out the back window because I'm like, how is this even happening? All right, sounds good. We got it now. So how many total events took place? 6. Okay, so on part A, the question is, after we roll an even, is that going to change whether or not we can get an even or odd on the next one at all? Or is it, no, it's the same dice, like, right? That has nothing to do with the next roll. So this would be considered independent events. It can't change. Like, a 6-sided dice is the same every roll. So it says, what's the probability of this even happening this way? Is that what this is? What is the probability of this even happening this way? So what's the probability that we'll do an even, odd? So let's talk about it. On a 6-sided dice, how many odds are there? And there are how many evens? 3. So let's just talk about the first roll. What is the probability it'll be even? 1/2. Then we move on. What's the probability the next one will be even? 1/2. Then what's the probability the next one will be even? Then what's the probability of the next one being odd? 1/2. So literally each time you just multiply the probabilities. Did I get enough 1/2s in there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, cool. And then you literally just multiply that together. So if you don't mind, think about it this advancedly with me. Couldn't I just, since these are all 1/2, go like this in my calculator? 1/2 raised to the 6th power? Let's just do that so it's easier to type it in. So 0.5 raised to the 6th power is, yes, if you want to do a fraction, your calculator will tell you it's 1/64. Because remember, your calculator can handle that for you. And then that's 0.0156. So to do the percentage, we move the decimal 2 places. So 1.6% chance. It's very unlikely that's going to happen. I've done this before. This is literally exactly what I've done before because I was talking about how crazy it is that one of my friends, she has 7 siblings and all of them are girls. And we were talking about how it was kind of unlucky for her Dad, that's a lot of girls. And so then my mom was like, what is the likelihood of that even happening? And so then I was like, it's literally a 1.6% chance, you know, because anyways, so it's kind of crazy. All right. Let's draw a picture here. A purse contains 4 $5 bills. I know. And 5 $10 bills. I'm just drawing a visual for fun. 1, 2, 3, 4, 5. And 3 $20 bills. It says 2 bills are selected without the first selection being replaced. As soon as there's not replacement, it's conditional probability. It's dependent. So it says, what's the probability you'll draw a $5 bill the first draw? And then what's the probability you'll then draw a $5 bill? So first, I would write myself a note. First, how many total bills are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Aren't there 12 total bills, everybody? Okay. So what's the probability if I put my hand in right now, I'll draw a 5? 1, 2, 3, 4. 4 12s. True, everybody? Okay. Now, if I've taken out a $5 bill, look, I'm going to cross it out. Now, for our second draw, the total is different. It's really easy. I mean, what's the total now? 11, right? There's only 11 bills left. Do you guys see what I'm saying? Our new total. And then it says, what's the probability we'll draw a $5 bill? Well, now there's only 3 out of 11's chance. And then you literally just multiply those probabilities together. It is easy. 4 12ths times 3 11ths. I don't know if I need to use some parentheses. Okay, 1 out of 11, which 1 divided by 11 is 0.091. So 9.1% chance.
Wait, on those, do you want the final answer be the percent?
Yeah. Just because probability is saying what percent likelihood, technically. Okay, questions? So it's really easy when it comes to this level of, dependent events. Okay, a bag contains 6 red, 5 blue, 4 yellows. 2 marbles are drawn, but the first marble is not replaced. So again, dependent. So what is the probability that we get a red then blue? So let's do ourselves a little note. On the first draw, how many total? Total. 6 plus 5 plus 4, right? Okay. So it's red the first time. How many red are in there?
6.
Okay. 6 out of 15. When we put our hand in, there are 6 red currently out of 15. Then let's do our second draw. Now the total is changed because we're not replacing.
Pardon the interruption. Can I get Nathan Johnson for checkout?
Yep. But keep in mind, okay, so now it says, what about then blue? So now how many blue are there in there still? There's still 5, but it's out of 14 now. And then you literally just multiply the probabilities. 6 15ths times 5 14ths is 1/7. I just did it in my calculator. I let my calculator simplify it for me, and then that's 0.143. 14.3% chance. Okay, so it's pretty easy. Would you guys agree? I feel like this is the easy part of the lesson. It makes sense why, you do it this way. Okay, read this one. This is problem number 9 off the homework. So once you get to the actual homework, you could say, did it on packet. There are 6 boyos and 5 girls in the class. The teacher randomly selects 3 students to answer questions. The first student is a girl, the second student is a boy, and the third student is a girl. Is this dependent or independent?
Independent.
It says 3 different students. So it's dependent. As soon as the teacher picks someone that's not you, there's more of a chance next time she's going to pick you, right? because there's less students, you know? So it's actually dependent because you're not replacing the student, you know? The student can't get picked twice. Okay, so let's do first pick. How many total?
11.
There's 11. And it says, what's the probability that it's a girl? So how many girls right now? There are 5 girls out of 11 total students. Then second, the teacher picks again. But now let's write our total. Isn't our total now 10? Then how many boys is there? 6 out of 10. Then let's do our third. Our total is now 9.
4 out of 9.
And there's not 5 girls in there anymore because we've already picked one. You're right. There's 4 girls. Do you guys see what I'm saying? Because we've already picked one girl. 4 ninths. And then you just multiply those numbers together. 5 elevenths times 6 tenths times 4 ninths is 0.1212, so 12.1% chance. I didn't write down the fraction because I'm jumping right to the point. Is that making sense? You just kind of think about it a little bit. Okay, now this is where it gets weird. It really is. I was reviewing for this lesson last period, and it's not that it's hard, but it's weird for students at first because it's hard to think about without actually using a formula. Okay, so I need everyone to lock in so I can explain this well. Okay, so we're now going to bring back in last time's lesson a little bit. So remember that we were looking at conditional probability last time, and the formula for finding something given that something's already happened is by this formula. We're going to use this a lot. So we all had to memorize the probability of A given B is equal to the probability of A intersect B. Remember, you keep order the same, A intersect B, right? Divided by probability of B. Remember the second thing goes on bottom, right, everyone? To help you memorize it, yes or no? Am I making sense? Okay, so if you're doing probability of B given A, B and A stay in the same order. It's B intersect A, and then divided by probability of A. Once again, notice the second thing is what we put on bottom. So here's a fun fact. You can actually determine mathematically if things are independent versus dependent by just using math. A minute ago, we just thought about it, but what if they forced you to show it with algebra? Then you'd have to use this knowledge. So fun fact, if 2 events are independent, then what will happen is when you calculate A given B, it calculates the same as the probability of A. So that's what I'm telling you. If it's write it down, independent, this will for sure happen. So if they said, are these events independent, you would go calculate A given B, then you'd go off to the side and calculate probability of just A, and if they're the same number, they're independent. You guys see? You would just calculate them individually and compare them. Are they equal? If they're not equal, then it was dependent. So if they're asked, are these independent events, you could go calculate B given A, and if B given A is the same as probability of B, then they're independent events. So you have to memorize what's what. So again, A given B, if it's independent, will be probability of the first thing. See? Probability of B given A, if it's independent, will be probability of the first thing. So that takes a little memorization. Now watch. Okay, so I just want you to jump down to this. Okay, so sometimes we're going to use this formula. We just learned if let's write this right here underneath. If 2 events are independent, this will be true. This calculation will be true. Now this formula is useful because in a minute they're going to give us basically kind of like almost like a puzzle to solve. They're going to give you missing pieces. Sometimes this formula is useful, but sometimes a more detailed formula is useful. Isn't there a way to be more detailed on A given B? What is that actual formula? We learned it last time. That would be the probability of A intersect B divided by probability of B, and that will equal, see, like right here, and then what will that need to equal if they're independent? Probability of A. So sometimes you'll be able to just use this top formula, and then sometimes you'll need a more detailed formula. This is also true. It's saying the same thing. This just has more detail to it. This is showing, well, this is the formula for that. Do you guys see what I'm saying? Okay, so same thing here, watch, because this is going to come up a lot. We're going to do a bunch of examples. So if you're doing independent, you know this is true. So you could say, I know for a fact this is true, but let's get more detailed again. So you'd rewrite this side as probability of B intersect A divided by probability of A, just because that's what that formula is. And if it's independent, that must equal probability of B. So you're going to see me in all of the examples write down both, because here is the thing. In a minute, we're going to have a puzzle, and sometimes this formula will be useful, and sometimes this formula will be useful. And sometimes you'll literally need both to answer their questions. So I always write down both. So let's go to my first example. So this is actually problem number 1 off the homework. So everyone read this. It says, determine if the events are independent or dependent. Oh, really?
Yeah.
9 out of what?
63 out of 20. 63 out of 200.
3 out of 5 though is fine? 63 out of 200. Okay, good catch. All right, so that would definitely change the problem, so I'm glad you noticed that. Okay, so here's what I would say. If we're dealing with independent events, I know 2 things are true. The probability, now I'm going to do it in the correct order. Do you guys see how they have A intersect B? So I'm going to choose A given B then, because that's the order it must have been. So we know 2 things. Yes?
It's not over B or whatever.
Yes, it's not, because these are just statements that are part of the puzzle piece that we're going to fill in a minute. So what are the 2 formulas we know? The probability of A given B will be what if it's independent? Probability of A. Let's write down the other, more detailed formula. So don't we also know then the probability of A intersect B divided by probability of B is the more detailed format of this. Do you guys see what I'm doing? Which needs to equal, same thing, we're just writing more details here. Now, if you look at the information given, is the top formula helpful or the purple formula? The purple. Look at the information up here. Is there a given? No, then that's not helpful. So you're going to say, I'm going to use this. Literally now it's a puzzle piece. You literally just put stuff where it goes. So what goes on the top position here? What number?
63 over 200.
63 over 200. Then we have a divide sign. Then we have probability of B is 3/5. And that needs to equal probability of A. Do we have probability of A? 9/20. So we're told, are these or are these not equal? If they are equal, what would we say? Yes, it's independent. What if they're different numbers? Then it's not fitting the statement. So then you would say, no, it had to have been dependent because those aren't equal. If they are equal, they're independent. So I literally go to my calculator and I let it do all the hard work for me. I just type this side in. Literally, I just go parenthesis 63 divided by 200, close parenthesis, divided by parenthesis 3 divided by 5, and then I hit math, enter, enter. Did anyone else do that? I get 21/40 equals 9/20, which is not true, so it must be dependent. Because this is saying it's independent. This statement would be true if it's independent. So this is kind of like I said, it's just a puzzle piece that you fill in the dots. And something different will be missing each time. So let's do another one. Well, I guess these are questions on that one. Okay, so once again, when I see this, I see that they've listed A first. So I'm going to go A given B. If it's independent, that will equal the probability of A. How do I know that? I've memorized it. We then write the more detailed formula of that. Probability of A intersect B divided by probability of B, which is a memorization thing, equals the probability of A. Once again, I always ask myself, which one am I using based on the information given? Well, I see intersection, so I know I'm going to use the purple formula. This is 11/80 divided by 1, isn't B 1/4?
Yeah.
And then we know it should equal 11/20. So that was the same level of difficulty. 11/80 divided by parenthesis 1 divided by 4.
11/20. No,
11/20
Yeah.
it's independent.
equals 11/20. So we'd say independent because this is the formula for independent and it worked. So pretty easy if once you've seen it. Okay, this one is different. Look, we've got to do this one. This is one off the homework. Number 5. So I say, okay, probability of A given B equals probability of A. And then I also write my other formula just in case. Probability of A, and I like to change up the color so I can talk to you guys. A intersect B divided by probability of B equals probability of A. Do we need the less detailed or more detailed?
Less.
I don't know, let's see. So, okay,
Not true.
that is 1/5 equals, and that is 1/4. You're right, so that one was easier. You'd say dependent. We didn't even need the more detailed formula. I always write them both down though, because there are times I'm telling you when you're gonna need both in the future, in the minute. Those ones are proving. Okay, see now we're finding the missing piece. So you do the same thing. To find a missing piece, you need a statement to connect all of these. And the one we learned today was a statement that connects all of these is an independent statement. Now, I believe if I'm not crazy, I didn't write down the instructions. Does your paper say that these are for sure independent? It doesn't?
No, it does. It says.
Okay, because if it didn't say that, I wouldn't be able to assume my formula is going to work. Okay, since it says in the instructions that these are independent, you're going to write out both formulas. The probability of A given B equals probability of A. We know that for a fact since these are independent. Then we might need instead the more detailed formula. I always write them both in case. Because sometimes you'll actually need both formulas and sometimes you'll only need one or the other. So if you look at the information given, wouldn't you agree it's the purple formula we need?
Oh, yeah.
So let's put instead of question mark, I'm going to call it X if that's okay. Doesn't that go there? So X divided by what's probability of B? 11/20 equals probability of A is 3/4. Now from here, this is basic algebra. This is literally solving like a 4th grade level problem. Get X alone. What undoes divide? So you're timesing by 11/20 to this side. Nope, because we're not dividing. We're just timesing it over, straight over, aren't we? If we were going to keep it on this side and then flip and multiply it, that's just stay on the same side, just to go up, which we don't care to do that. So X equals 3/4 times 11/20, and they're going to want a fraction if they give you a fraction. So just let your calculator do it.
33/80.
33/80, and then math enter, that's as good as it gets. So that would be your answer, 33/80.
So we're just solving for X.
Correct.
Yeah, that's what it says.
Okay, I'm going to do one more off the homework. 13. Again, I go, okay, because I'm told they're independent, the probability of A given B, make sure you go in the correct order. The reason I'm choosing A first is because so far it's always been A intersect B. If it was B intersect A, I would do B given A. Equals probability of A, since they're independent, which the more detailed formula, just in case I need it, probability of A intersect B divided by probability of B equals probability of A. So looking at the information, our X this time is P of A. So let's fill in the dots. Do we know this piece?
Yeah.
7/20 divide. Do we know this piece? 7/10. And then we have equals X. We didn't even have to solve then. Like literally now just type that into your calculator. Like X is alone. It's what? Okay. You just probably did it by hand. 10/7. The 7's divide out 1/2. 1/2 equals X. Good. But your calculator could do that for you if you are needing to do it in your calculator.
What's BIA?
Okay. Okay, almost finished. Okay, see, look at this one with me. I think this is we're getting there. Okay. Again, this time they said B given A. So B given A equals probability of B. Do you guys agree? That's what we're writing. I knew to go in that order because I looked here and saw, oh, they're doing B first. The more detailed formula then here, probability of B intersect A divided by probability of A equals probability of B. So do we need the pink or purple formula?
Pink.
Okay, let's roll with pink. What's that? 3/10 equals X. Oh, okay. 3/10.
Well, that was easy.
We just put in what we know. This is a true statement and this is a true statement. We picked the easiest true statement, pink.
Last page, baby.
I'm already done.
We memorized that last time. When you say it will always be B on the bottom, what do you mean by that? Somebody was saying that. I heard it.
Oh, I wasn't here last time.
Oh yeah, we just memorized that. That's how you do. So you always do the second thing on bottom.
Okay, so then if it was like the opposite was A, B, then B.
Correct. Okay, again. See, this one you need both formulas. Ooh. Okay. So the probability of A given B equals probability of A. That's the simple independent formula. We need also the more detailed. So A intersect B divided by probability of B will equal probability of A. So when I look at, isn't this our X? Yeah? Let's start there. X. Then I have a divide sign. Do we know that?
Yeah, 1/5.
Okay. Do we have the probability of A? Nope.
Because we have PA line B or whatever.
Exactly. So in a roundabout way we do, because look, isn't 1/20th that? 1/20th equals probability of A. So let me ask you again, do we actually indeed have probability of A? Yes. We do. We got it from the first formula. So you're like, oh, actually that is 1/20th. So I used both formulas in that one. They told it in the instructions that it was independent. So that's why we're able to. What? But did it give that? It was independent? I think we just assume that it continues from the last. We must be, because there's no other way to connect these. Okay, so solve for X now. Does everyone see what I did there? I still have people saying like, what? I got stuck here. I was like, no, P of A. So then I went to the other formula and I put in what I know. And I know that that's 1/20th. And I'm like, oh wait, that's what we needed was P of A. So I put it in. You know what I mean?
Okay, so 1.
So how do I algebraically get X alone? Times by what? 1/5. Don't flip. We're not. You only flip and multiply if you're staying on the same side. If you're just timesing it over, you leave it. So X is equal to 1/100th. Right? Okay. It started with fractions, so I'm going to leave it as a fraction actually. Okay, and then this is problem number 20 off the homework. Yeah, let's try this one by ourselves.
Okay.
And then we'll come back together.
I did it wrong.
Why didn't you switch them to X?
Yes?
We have an X on the bottom.
You
It's just algebra.
You just multiply this. No, you divide this. So it's 2/5. Because this is being divided with the opposite of division. Wait, no, this is multiplying, so it's the opposite of division. You know.
I don't know if he explained it right. I didn't listen.
I saw that.
You can divide. Yeah, you can divide.
10 you'll see it. Right, Miss Philman? You get 10
I'm not finishing it quite yet because I'd rather finish it all together. Okay, I'll just hurry and do it, and then I'll tell you if you're right. How about? Good job. It is that. Oh no, 10/3. Do you mean? Are you like saying that backwards? 3/10.
That's what I got first. I have 3/10 and
Is everyone ready to see the answer yet or not yet?
Yeah, I got it right, Miss Billman, don't worry.
Yes?
It's on my paper.
3/10. Yeah, I will, but I want everyone to like get a second. Are we getting 3/10 out there? Okay. Now, if you're not getting it right, you're having a hard time with, once again, basic algebra. And I don't say that to shame you. I just don't want people going and saying, oh, probability is hard. No, you're having a hard time with algebra. And this is, you guys listen, this is why people fail calculus, is things like this that they can't do. It's not calculus that's hard. They can't simplify something like this. You guys see what I'm saying? That it really all comes down to your algebra and calculus, whether it's easy or hard for you. Okay, so watch my algebra. I have really great algebra because I practiced over the years. And it's developed because I didn't always. I actually went into calculus with terrible algebra, and that's why calculus is hard for me. So watch. If I'm solving for x, I want x out of the denominator. So the first step is to times x to this side. So I'm going to show all my work. So we have 3/25 equals 2/5 times x. Do you guys agree? Now keep the goal in mind. We're trying to get x all alone. So what would we do now?
Times 2/5.
No. What undoes multiplication? Divide. Just divide by 2/5.
All my work says this.
So x equals 3/25 divided by 2/5. Does that make sense to the people who it didn't make sense to before?
I literally got
Okay,
it right. I knew it.
3/10. And then you can just do it in your calculator. Now, let me be clear here. Advanced people would not actually do that. Want to know what they would do? Watch.
I skipped it.
Watch what advanced people would do, which is fine to not be advanced. Sometimes it takes time to get there. Watch. Advanced people would say, I'm not going to divide by 2/5. I'm actually going to times by 5/2. So that's 15/50 equals, isn't that going to make that a 1?
That's what it is.
1x?
That's really advanced.
It's really advanced. It's just thinking about it differently. Do you guys see what I'm saying? You're creating a 1 by multiplication instead of division.
Yeah.
Yeah. Okay. You get the right answer either way because 15 and 50 both divide by 5. So then that would be 3/10, just like we got. So I do push you and I do implore you to try to think like that so that you become one of those advanced people. Cool. All right, that's the end of my lesson. Hopefully that made sense and those tricks helped get you going. I find that's very hard for kids without doing it the way I showed you with the 2 formulas. Okay, time's yours. Finish up. Let's not have homework over the weekend. How great would that be?